you very much for coming through to Rabbiteer. We're super excited to present our second Rabbiteer session. This session is all about DevOps, from code to users. So basically I will start off the session and I'll give you a bit of overview around more the concepts behind DevOps and why you should actually care about DevOps and what it means. And then Silje will take it a bit further and he'll make it real. He will bore you with all kinds of fancy technologies and code and I don't know what else. So let's get started. Who of you have felt like this guy? I have no idea what DevOps means, and this point I'm afraid to ask. Yes, that was me. That was me a year ago. And if you are in any way passionate about the IT environment and software development, you will feel like this monthly, bi-monthly, yearly, because every year there is a new buzzword that people throw around. All the management consultants are selling it to the big corporates. All the cool kids are doing it online. But no one actually really knows what DevOps means. So as a software developer or as someone who's passionate about the industry, it's our job to actually go into more depth around what is this DevOps thing and why should I care about it? Who of you know Amazon? Okay. Who of you actually use it quite regularly? Okay. Who of you know how many active monthly users they have? That depends on your source, but it seems like most people think it's around 250 million active monthly users. So that's quite a lot of users to have. That's quite a responsibility you have as a software developer to keep all those 244 million faces happy. What is Amazon notorious about? What do people write about Amazon? Come on, I don't want to talk alone. Yes?
Well, everyone knows Amazon is an online shop, but actually they make most of their money doing their online web services.
Okay, true. So it's an online shop, most people use it. Is it a good experience shopping on Amazon?
No. Yeah, it's pretty shit.
Wrong answer, okay. Okay, so their user experience sucks, I would give you that. But I mean, are their services stable? Okay, have you ever experienced the downtime on Amazon?
Well, 2 months ago there was an hour downtime.
Sure, so when Amazon goes down, people know about it because it doesn't happen often and a lot of people get affected by it. What else is Amazon known for?
Well, I usually mostly use AWS, that's why I know it.
Fair enough. What are some bad press that Amazon gets quite a lot? Amazon's a notoriously bad place to work for. They have like a culture of being driven by, I don't know what, but people leave daily. It's one of the worst places to work for. Exactly, people in Silicon Valley, they joke about working at Amazon because you get no benefits, you work your ass off, and you're on support 24/7. So how does Amazon get it right? They maintain a website which is being used by 244 million people monthly, but they manage to keep this environment stable. So, how do you do that?
DevOps.
Thanks, Jade. So, who knows how many software updates Amazon pushes in a day? How often do they release code? Any idea? Anyone want to take a wild guess? Jade, don't we have prizes for someone who... No, you're not allowed to answer.
Yeah, good idea.
Don't we have a prize to give to someone who gives us the right answer? You get free beer, yes. Who wants a free beer? Anyone want to take a guess? How often does Amazon update its code base?
Hourly?
Hourly is a good guess. More?
Half hourly.
Every 3 minutes.
Every 3 minutes is a better guess, yes? So you're getting warm.
So what's it, 1 minute?
You guys are no fun. Okay, so Amazon deploys code every 12 seconds. That is insane. I mean, sure, they have more than 300,000 people working in the company, so obviously deploying a lot of code is part of what they do. But imagine maintaining this environment where you have 244 million active users and you get updates every 12 seconds. This is a nightmare. I would not want to work there. So how do they do it? And thanks, Jade. Yes, DevOps is the answer. Okay, so why should we care about DevOps? I think the easiest way to explain it is development does not happen in isolation. If you're a hobbyist, someone who codes in your spare time, building your own private porn server, you sit in your basement, you write your code, you compile, you run it, it works, you're done. In the real world, that is not what happens with software development. If you're a professional software developer, you have a lot of stakeholders from a lot of different places. You are working in a team of anything between 10 and 200 software developers who all care about the stuff you wrote. You are working with a bunch of business analysts, with a bunch of other stakeholders who are not technical, and they actually care about the code that you write because your code impacts their business and your code impacts their daily life. So you should care because you're not working in isolation. You're not in your basement compiling your own porn server. So software development does get compared a lot to building a house. So these folks are building a house. What advantage do they have over software development? Any guesses? Once again, I need a prize. Jay, I need a prize.
Not a creative solution.
It's not creative, yes, that is one thing. They're standing next to each other, yes, they're co-located, that's part of it, but what else? What big advantage do you have if you're building a house?
They can see the whole damn thing.
Yes, thank you, give that man a prize, please. So if you're building a house, everyone, all the stakeholders, all they need to do is go on site and look at the thing, and it's there. There is complete transparency during the whole process about exactly what's going on. If that guy put the brick in the wrong place, you'll see it immediately. You'll be able to act immediately. You'll be able to fix it. Everyone has a complete view over what's going on. So that is the goal of DevOps, essentially. It is about creating that visibility, creating that continuous deployment, creating that active picture about what's going on in development in real time to all stakeholders. So yes, if you read the online about what DevOps is and whatnot, it's a whole list of technologies and tech stacks and processes and whatever. And those are the tools we use to be like these guys, because we want to be there. If I make a mistake in my code now, I want people to see it immediately, and I want it rectified, because then we can react, and we can change, and we can fix it. So on the right-hand side, I drew a small, really ugly diagram about typically what happens in a professional development environment. You get a couple of developers. I call them, you work on your local instance. So meaning I got code on my PC, I type numbers, things happen, I compile, I think I'm done. I push it to my source repository. This is easy, once again, if you're writing your own porn server. If you are collaborating with 20, 30, 40, 500 people, this becomes much more complex because the little bits of code you just wrote actually impacts everybody on that project. So what people started to do is they said, yes, you can work locally, but let's also create a dev environment or an integration environment or whatever you want to call it. So this is where everybody's code comes together and we try to test whether your change actually impacts something someone else does. In a traditional environment, you would also have some sort of a test environment. So there will be a battery of testers who just sit there and try to break your code. And everything that's highlighted there in white was typically part of something we call the build team or the development team or name it something like that. But the main idea behind it traditionally was that if I can prove my shit works in test environment and the tester ticks it off, I'm done. I don't really care what happens in pre-prod and production. It's not my worry. That is the worry of the run team. So what typically happens is you get build team versus run team. Run team usually asks, what kind of hardware do you need? We send them a list of hardware. Typically, we don't know what hardware we need because we actually don't know how many people are going to use it. We don't know what kind of servers they have. We don't understand their environment. So we send them a random list of random requirements that we Googled. So when people ask me that, I will Google what is SQL Server's requirements. I'll copy that, paste it, send it to the run team. Because there is actually no accurate way of knowing your exact infrastructural requirements until you actually put your code into production. So there's this whole thing about build team versus run team. And I can tell you many stories about how that goes sour. A typical response from a developer is, No, what do you say? It works on my machine. Okay, who has never said that? Okay, at least you guys are honest. I give you that. So what DevOps actually tried to do, DevOps says that working with a team requires collaboration, coordination, and control. So if we want to work together, we can't have this us versus them mentality. You as a developer are actually responsible for your code on production. So that means we need to give you the tools and the processes to be able to touch production. Put it like that. Okay, and as I just said, one does not simply deploy to production. If you've ever worked in a corporate environment, you would know production is holy. If you get access to a production environment, well done. That's all I'm going to say. Yeah, don't tell anyone about it. They will revoke your access immediately. So Leo would know quite a bit about that. So I'm making the hypothesis, and I'm saying that DevOps is not a technology or a tool. It's a mindset, or it's a way of working. So given all the background I just told you about, we want to work as a team, we want to give visibility over the whole development environment to all those stakeholders, we need to do three things really well. We need to automate, we need to do this continuously, and we need to have control over what we're doing. So when you read online and someone talks about DevOps, you'll get a whole list of continuous. So continuous integration, continuous deployment, continuous testing, delivery, feedback, improvements. There's a whole list of continuous. That's probably half of it. So Leo will probably show you tools that does any of it or all of it. Automation. So to be able to do things continuously and repeatedly, you have to automate. You have to automate your builds. You have to automate your tests. You have to automate your deploys. Even going as far as automating your recovery or automating scaling. So if your server is, or your service is not performing as you expect, it must have the ability to get more servers and more resources. So it's all about automating everything, all the way from development into production. But to be able to do that continuously in automated fashion, you also need control. So you need source control, very important. I know there are still people not using source control. It's freaking me out, but it happens. I worked on a project where I got code on a memory stick, and a month? Yes. So it still happens. Continuous integration pipeline. So you need to control the whole pipeline from your development environment all the way through to production. You need to be able to monitor what's going on in production. So you need to aggregate your logs. You need visibility over your logs. You need to know that if there is an error in your log, that someone can actually see it. Containerization. So you need control over how your stuff is packaged and deployed. So buzzwords, Docker, and those things, I'm sure Silvio will talk about it. But Docker comes into control. The control of how things are packaged and deployed is moving to the developer, because we want responsibility to take this all the way through to production environment. And infrastructure. So we want control over infrastructure. Gone are the days that we send an Excel spreadsheet of servers to some department who will source us VMs. We actually want to write a script that defines our infrastructure. So this is where things are going. Kubernetes, all the other fancy things, this is all part of having control over your source code in the production environment. Yes, so I will now in detail go and explain each and every one of these blocks. But a question people ask is, how do I know that I'm good at DevOps? I don't know I'm good at DevOps. Who wants to answer that?
Your shit running.
Your shit's running. That's a good measurement.
You deploy every 12 seconds.
By all means, without pissing off your 244 million customers. Yes, that is a really good measurement. So a lot of companies measure their DevOps success based on the amount of tools they have in their tool chain. If you talk DevOps, you will typically get 50 very confusing technology stacks, and people try to confuse you about the detail. But I think it's much simpler than that. As I said, it's not about the tools. It's actually about the mindset. It is about, can you recover quickly from a disaster? How big are the lead time from when you actually written your code and you say you're done with your pawn server until your pawn server is running live on 40 servers? the percentage of your successful deployments. How many of your deployments are actually failing? Deployments will fail. It's part of life. We're not 100% perfect, not yet in any case. So deployments will fail, and you need to measure that. How much effort does it take to deploy something? If you have to go and zip your files, you have to back up your database, you have to copy it to a server, you have to telnet into that server, then you do not DevOps. Then you are still in the Stone Age. Then you should probably invest into a combination of these tools to try and make your life a bit easier. And another thing is the amount of features and products that you can deploy. And I think if you look at Amazon, they have a buck ton of features and projects that they deploy on a daily basis without too much stuff going wrong. So I do think they're quite good at the DevOps thing. And I'm going to leave you with a parting thought before handing over to Celia. And what does DevOps mean to me as a developer? As I said, it's not about the tools that you know. Yes, it will help you to know Docker because it's an instantiation of one of these concepts that we're talking about. But essentially, DevOps changes your way of working. It changes your way of thinking. As a developer, your definition of done, so who are versed in Agile? Anyone? Okay. Definition of done means when can we move it from the swim lanes? So when can I take my ticket and move it? If you're truly DevOps, definition of done means your code is running in a production environment. Pushing it to QA, pushing it to pre-prod, that's not done. It's not done until it's live. And for you to be able to take on that responsibility, you need the tools and the processes to do that. And that is DevOps. And with that, I'm going to hand over to Celia, who's going to show you a bit more about the technical side, the actual tools that we use to do these things.
Do we have any questions so far? Yes. I'm going to give you a microphone.
Which business in South Africa would you rate as the top DevOps radio, doing DevOps well?
That's an interesting question, and I'm going to ask Francois probably to answer it, or Theod. Who's doing DevOps the best in this country?
That is a trick question, I think.
You said that! You were right.
I think from my experience, there are a lot of pockets of excellence within companies. So we get a lot of companies who have a couple of projects which they're actually doing DevOps in really well. I've been involved in a couple where it's a one-click deploy, testing is automated, deployments automated, builds are automated, everything just goes smoothly. But I actually haven't worked in a South African company where that is the culture. I think they're still they're trying it out. It's not mainstream yet. A lot of people claim to be DevOps experts, but they think if they use Docker, they are DevOpsing, and they're not. I see if you go and you measure them based on these metrics we said. I mean, most banks still have to take their whole sites down for a weekend to do a deployment. They deploy every 6 months, every 12 months. Now, if you use the measurement I had of measuring how long it takes from a feature, your time to live, that's not DevOps. They're failing at it. So I'm not answering your question, but I hope I am. Okay. Just on that, I think a lot of the startups, smaller players are doing it better, but I think it's probably mostly because their environment's much simpler. They typically have one product to support, or two products, or maybe even three. But I haven't seen someone with a huge array of 200, 300 systems that are actually doing it across all these systems.
You have to wait for the mic, otherwise we're not going to hear what you're saying.
So you mentioned culture. Why do you think in South Africa that our culture is not prone to, let's say, the one-click deployment thing where they want to manage every single stage of the process manually? Is it, I've had some experience where people are more, is it an age thing? Is it just people more stuck to the actual old way of doing things?
I think a lot of...
Well, Celia can answer because he has a mic.
So I think a lot of it comes down to the way companies are currently structured. most companies are structured around you have your development team, which hands over to your run team, which hands over to whatever. So it's developers are usually, if I can automate anything and I can put it for you in production live, I will do it now. But I think the bureaucracy around it in existing companies is still too big. And it takes a long time to change a company's culture. So that's why Amazon, Google, Facebook, these companies didn't exist 15 years ago. I mean, so they started with these culture or these concepts in the back of their minds. You now go into a bank or a big corporate, and they've started 18, 90 years ago.
So just basically too much red tape.
Red tape is a nasty word, but yes, a lot of legacy reasons behind it. I mean, previously that was the best way of doing it. Coordinating deploys, coordinating these things. The best way to do it was to have these rigid gates and these rigid checks. I think technology has caught up in the last couple of years by allowing us to automate these things and allowing us to deploy it. It's sort of new. It's not new, but it's new for someone who's been existing for 90 years. That's my opinion. I don't have a lot of stats to back it up, but that's how I would think.
And I could attest that, personally, I think many companies who are startups and don't do DevOps don't do it because they're lazy. It is very hard work. You will probably spend as much time writing tests as you're writing code, and you will spend as much time as you wrote all those things. You will spend time managing the process and your infrastructure and your deploy pipelines. It's really hard work, and you need to learn how to write bash scripts, as you'll see.
Lots of bash scripts. Okay, take it away, Celia.
All right, I'm going to probably repeat a little bit, but the first thing I just want to start with is the practices. So, like Theo said, DevOps is not really the tools and the practices. It's more the philosophy behind it. The goal really is to get from writing code to stable production as quickly as possible. Because then you can deliver business value as quickly as possible. But I'm going to go through some of the practices and I'm going to cover some of the tools, and I'm going to explain why this is such a big problem, why it's such a hard problem to solve. So, in order to be able to deploy your code to production every 12 seconds, you need to do certain things really right. And there are a number of things which a Google search will tell you people apply. So the first one is self-service configuration. So the idea behind this is you don't have static configuration. The services are configured inherently. So you would see things such as and by the way, I'm going to Alt-Tab between my presentation and the example code the whole time. So tell me to slow down if I go too quickly. So the idea is that you don't have. Let me give you an example. When we, at some of the clients where we work, do a production deploy, what we need to do is we need to make a list of all the configuration and send it to the people who will do the deploy, because it won't be a developer, and they need to apply it. And fingers crossed that it's correct. So what you want is all your configuration to be consistent within every environment. You're still going to have, by the way, DevOps doesn't mean you don't have a test and dev environment. It just means that it doesn't stop there. So in some of the projects where we work, we do have continuous integration to a development environment, but it doesn't go all the way to production. But in DevOps, you might very well still have a dev and test environment to be able to run all these unit tests and integration tests that we will talk about. A dark theme. Let's see if it helps. Color theme. Try that one. Let's try the high contrast one. High contrast. I will just do this. If I need to zoom. I really need like a podium. So I don't want to sit. I want to stand. So I'll just bend over. Anyway, What did I say? My goodness. Okay, I'm going to start going quickly because time is fleeting. Okay, so basically the idea behind self-service configuration is, for example, if I've got a Kubernetes cluster and I've got servers running, containers running inside Kubernetes, they can talk to one another without me needing to know in advance what the IP address will be, because it has a built-in DNS system. Other things, if you work with distributed systems like, for example, Hadoop, they have a distributed coordination system that keeps the services in sync. You don't need to go hard code the list of IP addresses of all the servers to get the thing to work. I'll show an example a bit later. Automated provisioning. Now, we live in a time where servers aren't real anymore. I cannot remember the last time when I logged into a physical server. I think it was when I worked for a Department of Water. They actually bought like 100 and something thousand rand server, and we were like, this is an actual server. If I crash it, it doesn't go back up automatically. So we have virtual servers, we have virtual load balancers, we have automatically provisioned IP addresses, and this doesn't even talk about the whole world of container orchestration, which just puts a whole nother layer of configurability. So automated provisioning means the infrastructure manages itself. It's part of the build process. It's part of the source code. We tend to think of the software as just being my source code. And if I run it, it connects to a database, but that database is somewhere else. If we want a stable system, what we need to realize is everything is the code. The database is part of the system. It's part of the ecostructure that I need to maintain. And automated provisioning means that's all going to be managed by the deployment process. Continuous build, basically, it's part of the kind of continuous integration thing. What that means is whenever I push code to the source control repository, it builds it and it creates a deploy artifact. Continuous integration. Now, continuous integration, many people think Travis. But I've seen many people who say, we do CI, and they don't. Because CI is not a new thing. It's as old as DevOps. And basically the idea behind continuous integration is your system is always integrated. When you write code, so I'll give you an example of what it's not. If you have pull requests, and that pull request stays open longer than a day, or longer than a few hours, you're not continuously integrated because you have multiple versions of the code sitting there that are not integrated. If you push to master the whole time, and that code gets built and tested automatically, that's continuous integration, because that's really continuous. When you push the code, you write code, you push it to master, that code gets integrated. That's continuous. It's the whole thing about Git flow and all these fancy, what do you call them? Branching models, and all these managing of the different lanes of your source tree. You have the develop branch, you have the master branch, you have the production branch, you have tags. That's not continuous integration. It's nothing continuous about it. It's very managed. Next one, continuous testing. Now this is probably the one where everybody kind of shimmies, because it's easy to do. If there is no test, it won't fail. So the first one is obvious. Unit test, you need to test your code. You need to write your code in a way that it is testable. E2E test, that's what I call it. They call it all sorts of things these days. That's basically automated testing. That means if you write a website, something's going to actually open your website in a browser and click on buttons and make sure the buttons work. Here you come to things like Amazon has, I think they call it a device farm or something. And what that is when you build an app, they automatically deploy the app onto an actual phone and run through a bunch of tests, clicking on places, making sure that it works the way it should. And this is where you will really work hard, because if you change something in the code, you need to change the test. But there's a side effect. That means you need to go actually test it. And it's going to work so well that a computer can test it. And that means the system that you built is so deterministic that every button click has a predictable result. And when you push and the continuous delivery software goes through the motions, it checks every commit, every version of the code. It checks that it works as expected. And the last one is continuous delivery. Now, basically, this is the process of integrating all these things and ending up with a production deploy. So the way that it works, and there's monitoring. I skipped one. I thought I had them all. Monitoring is the last one. This one is also really important. I'll just cover it quickly before I go to the next slide. Like Theo said, you need to be able to know if your site is working. I've worked on systems where we went to production and we kept asking them, are you sure you don't want analytics? And they say, no, we don't have time. And then we went to production and you're blind. You don't know if your program is working. There is no way to check. But just a side note, I mentioned analytics. Monitoring is not analytics. But analytics is monitoring light. Monitoring means knowing how many requests there are per second, knowing how many of them fail, knowing if they fail, why. And there are various, and I'll show you one way to do that in a minute. So this is continuous delivery. Like Theo spoke about, it starts with version control. You build it, it tests, deploys, it tests again. This is the end-to-end test, and then if all these pass the ideas, it goes to production, which means these tests need to be good enough that if it's not ready to go to production, these tests should pick it up and stop. And then at the end, measure, so that you know if something went wrong. Now, just a note on the build. The idea is that these things are deterministic. So if you build a version of the code, all of these work on that binary deployment. It's not necessarily binary, but that's the idea. It is, so this is where containers are very handy and VMs are very handy. You bake the VM. That thing will always be the same. If you go a year from now, you roll your code back to this revision and you build it again, it'll happen the same. That's the idea. And what that means is, if it comes here and this says everything broke, you can just go back to the previous version and kick off a build, and it will go through the motions, and you know your production system will be the same as it was yesterday. And that too you can automate by checking error rates. Okay, so I'm going to go through some of the tools. So I built kind of an example of how these different things integrate with one another. And the first tool I will talk about is GoCD. Who's heard about GoCD? No, nobody. Who's heard about Ansible, Saltworks, Puppet, Chef? Yeah, you just cover the bases. So GoCD is a continuous delivery server. Basically what it does is it does this whole pipelines thing. Every pipeline has a number of stages. Every stage does a specific task, and at the end it checks if it's good enough, and if it's good enough, it goes over to the next step. GoCD is very simple in comparison to the others. It doesn't have many bells and whistles, but one thing it does have, and that's why I picked it, is you can configure it in your code. You don't log into a server and click buttons and add scripts, because I find that that kind of binds you to that thing. Then if that thing breaks, your whole production deploy is gone. So with GoCD, the whole pipeline and all the steps, that's also put in your code. That's if you work with Travis, that's the way Travis works and Circle CI works. And just to note, the difference between a CI server and a CD server, a continuous integration versus continuous delivery, is basically continuous integration. Well, you can do both. You can do continuous delivery in a continuous integration server, but it's going to be hard, because continuous delivery server has these pipelines and these checks and this flexibility. It knows that maybe you want to go to yesterday's build and run that again, that kind of thing. I'll show you an example in a moment. I'll show you an example now. So I've got this server. It's running in the browser, so let me just put this in a new tab. Okay, here is the continuous delivery server that I made. Oh, you can't see, it's too small. So I made a site called dustmotes.com, and that's the Google random domain names that are available thing. This is the server. Now, the way you get this server running is just by the click of a button, and it will deploy the whole server at all its dependency to your Google Cloud Platform environment. But here the server is already created. By the way, when I started this, I had the idea that I will start from scratch and do everything. But I realized that that's just going to take way too long. So it's kind of cooking show. I already did everything. But at the end, I'll show you the Git repository, and you can go take a look if you want. So here you can see the different stages. And you can see it's gone through all of these. Checks, prerequisites, code checks, now more checks, build containers. That's your Docker and that. Prepare the dev environment. This actually creates the development environment, the servers needed for the development environment. This deploys the code to the development environment, and then it runs unit tests. And here we can see this failed, so it didn't go on to the next step. And then after that, test environment, unit tests, and then at the end, I didn't include production because I realized that I'm going to overrun my Google Cloud Platform quota, so I stopped at test. And you'll see why. You'll see why in a second. But you can see here, this system is the server basically does this, and I'll show you in the code how it's configured. Oh boy, I can't see what is going. There we go. So I've got this file down here, gocd.yaml. Because YAML is the cool thing to do these days. You can also do JSON. And here you can see there's the source code repository, and here are all the steps. Building, and it's just running scripts. Building, and it goes on. So if I change this and I push, it will change the whole system to do what I wanted it to do. Okay, back to slides. The next tool, and I'll try and go quickly because I realize we don't have infinite time. Terraform. Who's heard of Terraform? I can't remember the other name. Ansible and Puppet have a tool kind of like this. What this does is you give it a file that describes what you want your VMs to look like. What VMs you want, what domain names you want, what load balancers you want, all of that. And you click Terraform space apply, and it connects to your cloud provider, and it creates those servers. And over here, in the code, I've got gocd.tf, and here you can see this script. Well, the script, it's not script, it's kind of definition. Of course that doesn't work because I'm zoomed in. So here you can see it creates a firewall rule. It's got things like, it can take parameters, and then at the end, once it's created, it says, for example, set this DNS zone to the DNS of the server. Here we go. Name the A record. There we go. I can't see where it does it. Everything is so small. Anyway, so here's the definition of the server, Go CD server, and this will create the server. So I just run Terraform apply, and I can show you Terraform. No, not capitals. If I type in Terraform plan. It picks up the configuration file. It says, is this, it checks the cache, and it says, no changes, infrastructure is up to date. Now, if I were to change this script, it will check what changed, and it will apply it to the environment automatically. I'm not going to do that because it's going to take like 20 minutes to get the server back up and running. And the 20 minutes thing, if you create an actual VM, that's pretty slow. So without further ado, I'm going to go on to the next tools, because there's a better way to do it than just creating VMs. Kubernetes. Who's heard of Kubernetes? Who's heard of Docker, Swarm, Machine, and those kinds of things? So Kubernetes is Google's container orchestration system. And what makes it different from the others is it's made by Google. And Google kind of has been doing container orchestration for many, many years. And they basically made Kubernetes to say, this is what we've learned. We'll rebuild our container orchestration system working on Docker instead of they use their own container orchestration thing. And I've been working with it for a while now. It is very, very flexible. I'll show you in a bit what it looks like. But to give you an idea of what scale this goes up to, it's designed to run on 5,000 nodes. Now, when you open up a new account on AWS, you can create a maximum of 20 servers. This can run on 5,000 servers and hundreds of thousands of CPU and many, many terabytes of RAM. That is a lot.
Something I want to add, one of the cool things about Kubernetes is it abstracts your deployment from your provider. So you can deploy a Kubernetes configuration onto your on-premises environment or on any cloud platform, whether it's AWS, whether it's Google Cloud, whether it's Azure, or whether it's on-premise. Kubernetes will take care of it all.
And this is the important one, on your local machine. And that is key because we are living in a world where when we dev on our machine, it's different from when it runs. With something like Kubernetes, we have the whole environment that our system runs in on your local machine. And I'll show you that in a moment. But I just want to run through all of these different tools. So Kubernetes basically, you give it configuration of how you want your system to look. These are the servers I want. These are the IP address. These are the ports I want them to listen on. And it creates them all. And it's really quick. A Kubernetes cluster takes about 3 or 4 minutes to get up. And this creates maybe 30 CPUs and maybe 20 gigs of RAM. And then within that space, you can create your containers. And a container comes up usually in 1 or 2 seconds. So that's quite significantly faster than 20 minutes to create a server if you're doing a VM. Google Cloud Platform. Now, the reason I mentioned Google Cloud Platform because Theo said you can do it anywhere, and I've checked Azure. Azure has built-in Kubernetes support. Amazon kind of has it. You can make it work with Amazon, but Kubernetes was actually built on Amazon, and but on Google Cloud Platform, it kind of works automatically. Things like the load balancers and the persistent disks just get created automatically because they support it very well. And you can just go into a dialog box and say, I want a cluster with 500 nodes, and press run, and it'll create 500 servers for you, and your system can run on there. And it auto scales too. So it schedules your containers inside these nodes, and if it runs out of space, it just puts up a new one. That is very helpful. So the application is built in a language that many people don't like. But the idea of many of the systems we write in, for example, I've spent a real lot of time writing ASP.NET applications. And kind of the part of the reason why Microsoft is going over to the .NET Core, kind of that kind of way, is because an ASP.NET application is not very easy to configure. You can kind of make it work, but something like Node.js, something like Go, something like, I can't think of something else, Python, for example, your application is much smaller and lighter than it is otherwise. And so you build your application with the environment in mind. You can build an ASP.NET application. It's just going to be harder. And I'll move on. You can argue with me later. So when your system is running, you need to have in mind that you're going to have multiple servers. So every single system I've worked on with ASP.NET, except the brand sites for Talisure, has been one server. We're now living in an environment where you want to be able to create multiple servers automatically. So you need some way to coordinate that. And Apache Zookeeper is one of the services that you can use to do that. It's very simple in what it does, but it's invaluable if you want to build a distributed system. How many people have worked with Zookeeper? Jade has, because she works with Hadoop, right? There's other systems. There's quite a number of systems like this, like etcd, I don't know how to say it. And Console, anybody heard of Console? It does the same thing. I'll skip over that. Then, if you have multiple servers, you want to load balance. And the simple method is to just create the cloud load balancer, and that works fine. But has anybody heard of HA proxy? Has anybody heard of Nginx? So HA proxy is Nginx without the web server and many other things with it. It's a load balancer. It's a software load balancer. And it can handle something like 200,000 connections on a server with almost zero latency. And what you use this for is to load balance on your application. And this way you can control very finely how the traffic goes to your application. And the reason why you want to do this is because when you deploy, you don't want your site to go down. So if you're working with containers and you deploy, containers are immutable, so you kill it and you create a new one with a new version. But if you kill a container, it's going to lose traffic. So something like HA proxy can manage that and make sure that there is no dropped requests when you redeploy. It supports hot reconfiguration, and so that's perfect for that. Next, you need, yes?
Quick question about the tool. Does it support HTTP2?
Nope, it does not. If you want HTTP2 with HA proxy, just use it as a TCP load balancer. That's actually the reason why I chose it, because Nginx also doesn't support HTTP2 the way that I wanted to anyway. But you can use HA proxy as a TCP load balancer, and then it just connects directly to your servers. But that's kind of still, we really want a stateful HTTP2 load balancer, but we don't have that yet.
Lyft has Envoy. I've never used it, but apparently they claim great things.
Yeah.
What?
Envoy.
Lyft, the company, Lyft, has a service called Envoy. They open sourced it like 3 months ago.
Okay.
And it supports a lot of protocols, including HTTP2 and gRPC if you ever counted that.
So exactly why I'm awesome.
Yeah, so Lyft Envoy, yeah. That is a slightly different setup from Nginx and a proxy, but yeah.
Cool. Something to check out. Lastly, monitoring. Who's heard of Grafana? Who's heard of Graphite? Yeah, see, now we're in the more obscure areas of the internet. So the research that I've done, these things are really widely used, but they're only used inside teams, so no, you don't ever see it. So Graphite basically ingests metrics, and Grafana is a dashboard system, and I'll show you in a moment. But this is part of your monitoring. Graphite, you basically what you would do is you send all your requests, the request times, the error codes, and everything to Graphite. It aggregates it, and you can then query Graphite and say, what is the error rate on my application? What's the percentage of requests that are getting errors? What's the average duration of a request? Those kinds of things. And then you need end-to-end testing. Mocha, I guess Mocha is just Node.js end-to-end testing, and Phantom.js is, who's used Phantom.js? Who's used Selenium? That Selenium is more popular, but Selenium has a problem. You need a desktop environment. But Selenium also works with Phantom.js if you set it up. So you can, Phantom.js, by the way, is like Selenium, just is headless. You can run it on a server that doesn't have a desktop or a terminal or anything. So, architecture. So, I want to quickly show why this problem is so big. So, let us build an architecture. We want to build a website. It needs to be highly available. It needs to be able to do rolling updates. You're going to have a distributed system with many servers. You need coordination, you need database, you need caching, you need all this monitoring, you need all this proxying. So let's build that infrastructure. First, let's start with the thing I already mentioned. You need the coordination service. So Zookeeper is basically, you need at least 3 nodes. You can typically have 5 or 7, but let's say there are 3. So that's something you need to keep in mind. Now, think about building this in VMs or physical infrastructure if you're really brave. There we have 3 servers. So let's say you're using a messaging system like Apache Kafka. Everybody use Kafka? Am I saying it right? Kafka. One of our teams, the Kaleido team, is using it. Theo told me. I think they're using it. Basically, it sends messages between servers and can do it. It's a distributed message queuing system. Then you need database. So let's say we've got Mongo, and let's say we need a cache. We've got Redis. I bet you I missed. No, I didn't. So anybody worked with Redis? It's an in-memory cache. It's really, really fast. Just as long as you don't pretend it's a database. It's a cache. And Mongo, that's really nice. Also, if you don't pretend it's a database. We have nice arguments here at the office. Mongo is a document database. It's also distributed, but it's so hard to set up the distributed system that I just put one server there. Distributed databases is a really, really hard problem to solve. I'm not kidding. It is something that has obsessed the cloud world for years. It sounded cool. So Google has got a new product out called Spanner. That is kind of, the people are looking at it and saying, this is the closest we're going to get to having a normal relational database, because we really want a relational database, because something like MongoDB is just a key value store under the hood, whereas a SQL relational database has all the things you really want from a database. But the distributed database is a big challenge. But for now, let's just put a Mongo there. But imagine that it's 5 or 10 servers for a database. So here's our web server. Lots of them. There are lots of them because we're using Node.js. And Node.js is single-threaded. So we need lots of servers to be able to handle our traffic. Now, if we have lots of traffic and our web server is running, we want to monitor it. So we need our... Oh, I'll get to that. We need Graphite, but before we get that... so when you do a deploy, I just want to get to this because this is kind of integral in how you build your infrastructure. We've got this cool thing called red-green and red-black deployments and canary deployments. And what that means is you deploy in such a way that your system doesn't go down. And there are many ways you can do it. Canary build is kind of the one that's kind of standing out at the moment. And the way that works is when you do a production deploy, what you do is you create a new part of your system called Canary that has the new version of the code running on it. And what you do is you divert 5% of your traffic to that part. And what you do is you then monitor it. And you see if that new part of your system is getting more errors than the rest of your system. I know Google does this. I know Facebook does it. It's really hard to get it working, which is why not many people are doing, because it's not something tools exactly support. And I think Chrome does it as well. Like when they update, some people get the new version of Chrome, but not everybody does. And then they check, see if there are errors, and if there are errors, they roll it back and fix it. I think they just roll forward, they fix it, and then go forward. But that way you kind of know, you can put your code in production and check it in production without affecting all of your users. And then when you know it's stable, you update the rest of the servers with a rolling update or so on. And in order to do that, you need a sophisticated load balancer. So that's why we have something like HA proxy to do that. And then outside of your system, you also need load balancers, and these things need persistent disks. So what we have here is a pretty complicated system. The system that I built has something like 16 servers. And if you were to manage this, even if you're not DevOps and you're building a normal system, managing this is a very difficult task. That's why we have run teams and infrastructure teams to do the management for this. So that's why we automate it. So without further ado, I'll show you a little bit of how it works. So I've got it running on dust-moats.com. There we go. So this is the system that I made. It's got all that infrastructure that you saw, except Kafka. It's running, but it's not here. So there you can see 6 servers running. it knows there are 6 because it's connecting to Zookeeper. It's polling every minute, so you can see this keeps changing. It's polling every 2 seconds. This keeps changing as the load balancer hits a different server every time. The reason it hits a different server every time is because it's HTTP. And with HTTP, you've got a connection to the load balancer, and the load balancer has a separate connection. I won't go into details, who cares? So, and here you can click on buttons, and you can say, test Redis, and it tests, yes, Redis is working, Zookeeper is working, Mongo is working, and Graphite is working.
The mouse over icon.
Yes. Who cares? So this system is running with all those things that I showed you in the diagram, and I created it earlier today on Google Cloud Platform. I was going to show you how to do it, but it turns out it takes like 15 minutes, so I won't torture you more. But this process that you see here did it. It stops at unit tests because there's something slightly different in the Kubernetes environment on Google Cloud Platform than there is locally. Now, here's the project and all the code that you can see. So here's my web application. You can see it's got public and so on. And so how it works is it does basically what I described. It starts by building all the containers, and I've got all these containers, all these folders contain containers. There's a Docker file, there's another Docker file. It runs through them, it builds them, it uses a version tag based on the commit hash. Then it creates the development environment, and then it deploys to the development environment, and then it runs tests, and if all the tests passed, it's going to move on, it's create a test environment, it's going to do it again. The test environment would typically be the same as the dev environment, but publicly accessible with more servers. And by the way, in a system like GoCD, where you have the continuous delivery, there can be manual checks, because sometimes you do want to say, I want to actually click a button to go live. I don't want it to happen automatically, but in the DevOps mindset, you would have everything automated. And so here's the meat and bones of the system, is all the scripts that do all this. And that's the one challenge with doing this, is you're going to have to write a lot of scripts. You're going to have to write a real lot of scripts. I'm not kidding. It's every single thing that I just described needs to be scripted. So you need to learn how to do that. There are tools that can help you, tools like Spinnaker. Spinnaker is a bit of a more managed continuous delivery platform, but then you're going to learn how to use that. Let's see, what else can I show? So the Kubernetes deployment files that I'll quickly show you. This folder you see here contains our system. It's got the definition for every single one of the servers. Here we go. This is, for example, the Graphite server. It says those are the ports, and so on and so forth. The image, you'll see the image here. It says use this image, uses the project ID. Everything is configurable, and so on. And when I run the script, so let me quickly build it so you see how it happens. I've got a Kubernetes cluster running on my local PC, and I'll tell you in a moment why that's important. But let me show you what it looks like when I build all the containers. I've got deploy scripts, build scripts, and then utilities, and then let's say build Docker, build all. So this will build all the containers. It loops through all the directories, builds all the containers. Easy peasy. There we go. It took 8 seconds, and it built all the 10 containers for the 10 different systems we have. Is it 10? Maybe more. And then, let's say I want to run it locally. I've got a little script. Of course, I have a script. Everything's a script. To run it. Now, what this does is it creates a pod. A pod is like, pretend it's a server. Inside Kubernetes, it kills the existing process. It does npm install just in case I added dependencies. The internet is not magical, I noticed. It opens in the browser. There we go. Running locally. Exactly the same. It has Redis. And notice it has Redis, it has Zookeeper, it has Mongo, it has Graphite, it has all the dependency without me having to configure anything. There's no difference in the configuration between the development system and the production system because we have something like Kubernetes. You'll notice there's just one running. That's because it's not running. So let's see if we can get it running quickly. That will basically run the same script that we run in the production environment. It's only going to point to a different Kubernetes environment. Let's say, what's it called? Let's go to utilities and manage deployments. This is going to do all our deployments. Let's see if it works. I'm saying let's see if it works because I've been tweaking this stuff a lot today. It creates Grafana. I'll tell you what Grafana is in a moment. For those of you who don't know, it's really cool. Creates Kafka. This creates the servers on Kubernetes. And Kubernetes has a dashboard, so let me show you that so you can see what it looks like. I can go here to my local, I guess there. So this is Kubernetes. This is my local deployments. Here you can see there, these are busy being created. It's got replica sets that everything manages something. Scroll down. Scroll. Stateful sets, that's for things that need to keep state. Here's all my pods. Currently there are 20. 1 to 10 out of 20. You can see they all are. Let's see if it worked with the replica sets. So the replica sets managed, you can see here, it killed that one, it created that one, this one's busy creating. And so it does all this, and I just ran a command. That's really, this was not me writing magical scripts. Kubernetes really is very simple to work with. You just have to write this thing, which you get used to. So there it's running. Let's see if we got more servers now. Is this a local one? Here we go. This is the local one. Now you can see there are 4 servers running. So I deployed the environment. There are 4 running. It's magical. Now there are 7. The reason there are 7 is because the stateful set killed 3 of them and put 3 in their place. Okay. So I'm going to come to the last point, which is monitoring. So as part of the system, it puts a Grafana server on it, which is a really nice thing to have. So Grafana is a monitoring server. So this has been going on in the background. It's the live, well, the one that's running on GCP. And over here you see this is the average load time. This is 4 milliseconds. It really is quick. So if some people might concern like container is not a real server. Is it slow? It's not slow. The highest load time is like 10 milliseconds request duration. And here it tracks the number of requests. So if I were to go on the server, let's see where is it? Is this it? I'm going to refresh it a couple of times. And maybe, yeah, so if you want, take out your phone and go to that URL. And see if you can create some load. I'm going to do it on my phone. See if it works. dev.dust-moats.com. The internet is not amazing. We have like no 3G here. It's annoying. I don't know if my phone's going to work. Let's see. Load. Woohoo! Here we see we got some load. And zoom out a bit. We've got 30. This is pretty much per second, 30 per second. There we go. My phone finally worked. You can click the tests. Yeah, it's testing. It says little thumbs up for all of them. Let's refresh it again. Oh, what just happened? There we go. We see those orange ones at 304 is coming through as everything's cached. So that's pretty much the example we have. Now, just to get back to the DevOps thing, we've got all these systems in place. We've got Zookeeper and we've got Grafana to do the monitoring. And we built the system with DevOps in mind. We didn't take a system that was already built and squashed it into DevOps. We did a lot of work and wrote a lot of scripts, like a real lot of scripts, and built the application with the fact that we have no configuration. We already know we have no configuration, so we're building it. We're not cutting corners and hard coding IP addresses or anything. It's hard work to get this started. But now that we're started, I've got a development environment that will be exactly the same as the production environment. The only difference is my development environment creates 20 containers on my local PC, and the development environment might create 1,000, 10,000 containers on development production environment, and everything is consistent, everything is monitored, and everything is automated. And that's it. Any questions?
Yes, any questions? I think we've got 5 minutes before we need to start assembling some of the people who need to take the bus back.
Jed, I just think have people just read, because
Okay. Yeah, I agree. That was a lot.
No, everything is available on Git, right? And we'll circulate the link.
It's on my GitHub now, so if you want to go tonight, I'll give you the URL, but we'll put it on the Retro Rabbit GitHub tomorrow.
And there's a Rabbiteer Slack, so if you join the Slack, then we'll also put it on there. Also, if you're into social mediaing, we are #Rabbiteer2017. So please tweet and Facebook and all the fancy things. Yeah, we're going to send a feedback form. So if you'd also fill that in, that would be really awesome. Cool.
And I am on Slack if you have any questions. In order to, if you want to go and do this at home, you will need GCP, Google Cloud Platform trial account. Now, all you need for that is a credit card, so if you don't have one, go and borrow one. It won't build the credit card. You sign up for a free trial. It gives you $300 free credit. And that is quite a lot. Not a lot if you want to run a production system, but it is a lot if you want to go and test. I want to show you how much I've used so far. I've been toying around on it this week like crazy, if you can imagine, creating big clusters. I've used $40 out of my $300. So it can go quite a lot. And so if you want to play around, the code that I wrote here is specific for GCP. It will unfortunately not work on anything else unless you change quite a lot of scripts. The Kubernetes environment itself can run anywhere else. The deployment and so on, not so much. But if you want, yeah, that's there, and I'll put it back to this.
I have stickers for people with questions. We only got hold of them now. So any questions? Stupid questions? Well, there's no such thing as stupid questions. Cool.
I want a sticker. I asked a question.
I am 30 years old.
I think you get stickers, Francois. I think we can give you one.
Gerard, jy vra.
We have a question over here.
Standing like that. Yes.
How does all this deployment affect the performance on your PC?
You mean my PC? I'm running Kubernetes in the background. It's using like no memory. It's only got 2 gigabytes. So when you run Kubernetes on local, you've got a tool called Minikube, and it creates a small Kubernetes cluster in your computer. Cluster as in it just creates one. And it basically creates a VM with 2 gigabytes of RAM, and that runs locally. So my computer is completely out of memory. Well, not. It's got 13 gigabytes out of 16 gigabytes used. But Kubernetes is maybe 2. It's not. It wouldn't be 2. It would be more like 1. You can monitor the memory load. I'll show you quickly what the memory load is of the production system, which you're running. Let's go. I've got it here. So go to container engine. Zoom in a bit. So there's our cluster. It's got 5 nodes, 10 CPUs, 30 gigs of RAM, which is way more than it needs, but it tends to get finicky if it doesn't have enough CPUs running. So let's see, proxy P. So you know the Kubernetes dashboard I showed you? You can check out the one for a production cluster from the Google Cloud Platform, securely and all. And just type in their UI. It's a bit fancier than the local one. So here's the same system in a production environment. It's using less than a gig of RAM. And it's running 15 containers, 15 pods. It's 15 containers. That's including all our databases, Zookeeper, Kafka, our web services, and all of that. Gig of RAM using 0.05% of a core. It's not very CPU intensive. And you can look at the memory usage for each pod too. You can see this one is using 100 meg. This one is using 300. What is it? Kafka is using 300. Oh, the unit test one failed. That explains a lot. So that's the containers typically use way less memory and CPU than an actual VM because it doesn't have all the overhead of the operating system. Does that answer your question? Okay.
So containers basically they reuse the core. So your like Linux core, it's reusing the functionality and just creating separate little containers on top of it that kind of mimic a very light, so it becomes a very lightweight VM. I have a question.
Yeah.
What happens when Zookeeper messes up? Is something monitoring it?
If Zookeeper messes up, your system goes down.
Cool. Because this is a problem. Zookeeper can be difficult.
Yeah, so if you don't want to go Zookeeper, if you want something that may be different, you're gonna have the same problem. But there are just different kinds. There's etcd, which is simpler. It's more write specific. You've got console, which I think is also just a key value store. Console does a bit more. Console does too much actually. It does some of the Kubernetes stuff. So that's why I didn't use console. I didn't need DNS. Kubernetes already has DNS, those kinds of things. But yeah, that Zookeeper is supposed to have high availability. So it's something like up to a third of the servers can fail. But if it goes down, your system goes down.
Yes. Is it not moving the problem along somewhere else?
Yes, it is.
In a way.
It is, but it's kind of the problem is always going to move somewhere.
I suppose so.
You could build a system without Zookeeper. You could maybe be smart enough so that you don't need it. Like, if I didn't use Kafka, the only thing that was using Zookeeper is my application. And I maybe could have written around, maybe I don't need to know how many servers they're running. And you can totally do that and build your system around it.
I know, I just really want to use Kafka.
Kafka is nice, and the features that Zookeeper provides is very, very valuable. For those of you who don't know, it's a distributed coordination server, and coordination is the difficult problem with distributed systems. How do two servers work on the same thing without interfering with one another?
Cool. Yeah. Any more questions? Is that all? Okay, awesome. Great, thank you very much, Celia. Another round of applause for him. And we're going to have some more snacks. I think there are some for those who can stick around. We've got some Uber vans on the way. So for those of you who need to go to Jaxie over there. She'll make sure you get on an Uber van. Also, if you don't have a shirt yet, please go speak to Jaxie. She'll make sure you get your shirts. Once again, I hope you had a really good time. This is the first of many throughout the year. This is our second one this year. If you enjoyed this one, please let us know. If you think there's anything we could have done better, please let us know. And we'd really love to see you at the next one. So now you can sit back and relax and grab another drink and have some more food, or quickly get on an Uber. Make sure you grab some food before you get on. Thank you very much, and we hope to see you next time. Thank you.